Welcome to another exercise for the workbook statistics, this time with an exercise on the exponential distribution. Here our task is the average waiting time of a hotline is given as 2 minutes. You know the waiting time follows an exponential distribution. So we already have the first information, that's the average for the waiting time, which is our 2 minutes. In addition, we have two tasks to answer. The first being, what is the probability to not having to wait at all? And the second one, calculate the probability to wait between 0 and 5 minutes. Well, not having to wait at all means the probability of the waiting time being 0. Well, exponential distribution is a continuous distribution. So we're not calculating is equal to 0, we're calculating is 0 or less than 0. And here we're calculating is between 0 and 5 minutes, so larger than 0 but smaller than 5 minutes. Let's start with the first part. What do we already know? Well, it's exponentially distributed. That's of course due to the exercise focus. We also know what we want to calculate. That's, as I'm motivated, the probability that the waiting time, that's what the X stands for, is smaller or equal to 0. What we know from the exercise as given statistics is the average of 2. And well, if we know the average and we know it's exponentially distributed, we know that this factor lambda is actually 1 divided by the average. So 1 divided by 2 gives us 1/2 or 0.5. With this we have everything we need to calculate this probability, because we simply take the formula for the exponential distribution, which here in this case would be for smaller than 2, 1 minus e to the power of minus lambda k, k being the 0, lambda being the 0.5. So simply insert 0.5 times 0, meaning I get 1 minus e to the power of minus 1/2 times 0, or 1 minus e to the power of 0. Everything to the power of 0 is simply 1. So we get 1 minus 1, giving us a probability of 0. So the probability of not having to wait at all will be 0%. Well, that's already part A. So let's have a look at part B. In B, well, again, we're using the exponential distribution. And we want to calculate, as I mentioned before, the probability of the waiting time to be somewhere between 0 and 5 minutes. We can do this in a simple fashion. We just calculate that it's smaller than 5 minutes and subtract that it's smaller than 0. This makes sense and it's actually pretty easy, because the second part we calculated in part A. That was 0. So here this boils down to us basically only having to calculate the first part. Well, again, we know we have an average of 2, thereby a lambda of 0.5. So we can simply take again our formula for the exponential distribution. And as I mentioned, we have to calculate these two probabilities, but the second one we know from part A, which is 0. And for the first one, well, we simply go again, 1 minus e to the power of minus lambda minus 0.5 times k. The k here is the 5. So we get 1 minus e to the power of minus 1/2 times 5, giving us e to the power of minus 2.5. If we calculate this, we get in total 0.9179 or 91.79%. So there's a chance of almost 92% that you have to wait somewhere between 0 and 5 minutes, or in other words, less than 5 minutes. Well, that's what we will ask for in part 2, which concludes this whole exercise. So I hope you enjoyed it. I say goodbye and see you soon.